Adapting construction to climate and environment. Sustainable building design must adapt to local climate conditions, ensuring structures remain comfortable, durable, and energy efficient year-round. This involves insulation, weather resistance, and passive heating cooling techniques that reduce dependence on external energy sources. Insulation techniques for cold and hot climates. Proper insulation is key to maintaining indoor temperatures in extreme weather conditions. Different materials and methods work best for cold versus hot climates. Insulating for cold climates. In cold regions, insulation prevents heat loss, keeping buildings warm in winter. Best insulation materials. Straw bales, high R value, 30 to 50. Great for walls and roofs. Sheep's wool naturally regulates moisture and temperature. Earth-based materials, cob, adobe, rammed earth. Excellent thermal mass to store heat. Recycled cellulose, shredded newspaper. Effective, low-cost, and eco-friendly. Cold climate design features. Thick walls. More insulation equals less heat loss. Small south-facing windows. Maximizes sun exposure. Roof overhangs. Helps with snow accumulation control. Earth berming. Partially burying a house uses the ground's natural warmth. Insulating for hot climates. In hot climates, insulation keeps heat out and interiors cool. Best insulation materials. Reflective roofing. White paint, aluminum sheets. Reduces heat absorption. Bamboo walls. Allows for natural ventilation. Mud, clay, or adobe walls. Slow heat absorption during the day, cool at night. Thatched roofs or clay tiles. Provide airflow and prevent heat buildup. Hot climate design features. High ceilings. Heat rises, keeping living areas cooler. Shaded porches and wide eaves. Blocks direct sunlight. Cross ventilation windows. Enhances natural airflow. Courtyards and water features. Help cool surrounding air. Key rule. Use thermal mass for temperature regulation and airflow designs for cooling. Wind-resistant and flood-resistant building designs. Wind-resistant design, storm and hurricane protection. In storm-prone regions, buildings must withstand high winds and flying debris. Wind-resistant building strategies. Rounded shapes, example, domes, yurts. Reduce wind resistance. Aerodynamic roof angles. 30 to 40 degree pitched roofs prevent uplift. Hurricane ties and reinforced joints. Strengthen wooden structures. Underground or earth-sheltered homes offer extreme wind protection. Case study. Indigenous Pueblo homes use thick adobe walls and small windows to reduce wind impact. Flood-resistant design. For flood-prone areas, construction must elevate buildings and allow water to pass without structural damage. Flood-resistant strategies. Raised foundations. Build on stilts or mounds. Flood-resistant materials. Stone, concrete, or bamboo resist water damage. Permeable landscaping. Gravel, rain gardens, and swells reduce runoff. Breakaway walls. Allow floodwaters to pass without destroying the main structure. Case study. Traditional stilt houses in Southeast Asia lift homes above floodwaters, using bamboo and coconut wood to resist rot. Utilizing passive solar heating and cooling. Passive solar heating for cold climates. Buildings can trap and store heat from the sun to reduce heating costs. Key passive heating techniques. South-facing windows capture maximum sunlight. Thermal mass walls and floors. Adobe, stone, concrete. Absorb and slowly release heat. Dark-colored exteriors. Absorb heat in cold climates. Greenhouses attached to homes. Trap warm air for heating. Example, earthships use large front-facing windows and thermal mass to stay warm without heaters. Passive cooling for hot climates. Cooling designs prevent heat buildup and use natural airflow. Key passive cooling techniques. Light-colored roofs and walls reflect sunlight. Overhangs and vegetation provide natural shading. Thermal chimneys release rising hot air. Underground cooling tubes use Earth's cool temperature for ventilation. Courtyards and water features promote evaporative cooling. Example, Middle Eastern homes use thick stone walls, shaded courtyards, and wind towers to cool interiors naturally. Conclusion: adapting buildings to local climates reduces energy needs, increases comfort, and enhances disaster resilience. By incorporating insulation, weather-resistant design, and passive solar strategies, we can create sustainable, low-impact, and climate-adaptive homes.